Assalamu alaikum. I'm Engineer Hamna Shakir. In this video, I will solve problem number 107 that is related to axial stresses. The problem statement states that a rod is composed of an aluminium section rigidly attached between steel and bronze sections, as shown in the figure. Axial loads are applied at the positions indicated. If P is equal to 3000 pound and the cross-sectional area of the rod is 0.5 inch square, determine the stress in each section. So here you have got an aluminium rod that is attached between bronze and steel rods. At this location, the composite rod is rigidly attached. The cross-sectional area of the rod is 0.5 square inch. A force of 4P is applied here on the end of the steel rod, and here a force of P is applied at the connection between aluminium and bronze. Let's first analyze this whole rod globally, and then we will consider each part individually. So globally, you have two forces acting on this composite rod. One is 4P, this is tensile force, and the other one is P, that is a compressive force on the bronze. So if you globally see, you have minus 4P here, and you have got a positive P force at this point. So you have got minus 3P force acting on this rod globally. So you have got 3P force acting on this rod. If you find the reaction on this rigid connection, you will have a reaction of 3P here. So this is the global situation of this rod. You have steel here, you have aluminium here, and you have bronze here. So force of 3P is acting here, and you have got a reaction of 3P at the rigid connection. Let's now locally analyze this rod. Let's start with the steel section. So if you draw a free body diagram of the steel section, you have a force of 4P acting on the left side, and you will have a reaction of 4P acting on the other side. So you can say that a tensile force of 4P is acting on steel. Now for the aluminium, let's draw a free body diagram. So you have steel section here, then you have got aluminium. A force of 4P is acting on the left side, and you will have a reaction of 4P on the other side. So you can again say that a tensile force of 4P is acting on aluminium. Then you have got bronze. You can draw a free body diagram of bronze. So you have got steel, you have got aluminium, and then you have got bronze. So you have a force of 4P acting on the left side, and then you have a force of P acting in the right direction on bronze. So you'll have a reaction of 3P in the right direction. To further elaborate this, you have got a force of minus 4P because it's acting in the left direction. Then you have got a force of P acting in the rightward direction. It means that you have a force of minus 3P acting on this rod. So you have got a force 3P acting in this direction. That is why you have a reaction of 3P in the right direction at this point. So you can say that a tensile force of 3P is acting on bronze. If you want, you can also draw a free body diagram of bronze from this side. As we discussed earlier, you have got a reaction of 3P acting in the right direction at this rigid connection. So if you draw a free body diagram from this side, you have got a rigid connection with a force of 3p acting on it, and here you have got your bronze section, so it will have a reaction of 3p at this point. So you can say that a tensile force of 3p is acting on the bronze. So let's write it down here. For steel, you have tensile force of 4p acting on it. For aluminium, you have a tensile force of 4p acting on it. And for bronze, again you have a tensile force, but it is of magnitude 3p. The problem statement is asking you to determine the stress in each section. So we have got the forces in each section, and to find the stresses, you can use the formula stress is equal to force per unit area. Area of all the sections is same, that is equal to 0.5. So 4p becomes 12,000 pound and 3p becomes 9,000 pound, because p is equal to 3,000 pound as given in the problem statement. Now to find the stress in each section, stress in steel is equal to the force, which is 12,000 pound, divided by area, which is 0.5 inch square. You will get an answer of 24,000 psi, and you can write it as 24 ksi. You will have the same stress in aluminium as well, because force acting on aluminium and steel is the same, and so is the area of steel and aluminium. For bronze, the force is 9,000 and the area is same as for the other two sections, which is 0.5 inch square. So you have got a stress of 18,000 psi, which is equal to 18 ksi. So these are the stresses in each of the sections of this composite rod. If you want, you can also draw an axial force diagram of this composite rod. Let's try that. So let's draw axial force diagram of this rod. So you have got 4p acting here, a force p acting here, and a reaction of 3p at this side. Let's draw axial force diagram of this composite rod. This horizontal line represents zero force line. Starting from the left side, you have got a force of 4p acting here, and it's a tensile force. So let's represent tensile force as positive force. So it's a force of 4p. Starting from 0, you can go 1, 2, 3, 4 units upward. So you have got a force of 4p at this left side. In the whole steel section, there is no other force acting. So you will have the same 4p force acting on this steel section. This is the junction of steel and aluminium, and you can see here that no additional force is acting between steel and aluminium. So you will have the same 4p force in the aluminium as well. This is now the junction between aluminium and bronze. So here you have got a compressive force of P acting on the bronze. So if 4p here is positive and p here is negative, you will have to go down 1 p unit, and here you have got a force of 3p. So 3p force is acting on bronze, and then this 3p force will continue along the bronze section. Now this is the part where you have a rigid connection. At this rigid connection, you have a reactive force of 3p acting in the rightward direction. Because we are taking this left direction as positive, so we will take this right direction as negative. So you have got a 3p force acting here on bronze, and you have a 3p force acting here on the rigid connection in the opposite direction. So you can write 3p minus 3p, which gives you 0. So from here you can go back down to 0. So here you can see that you have got a 4p tensile force on steel. You have got the same 4p tensile force on aluminium, and you have got a 3p tensile force on bronze.